One of the most important concepts in programming is the concept of a loop. Loops are a way of repeating an operation many times in a computer with sometimes small variations. So today we'll look at for loops, nested loops, and while loops in Python. To get started, let's consider a loop like this. I'll say for I in range 0, 10, and then underneath that, well, then I need a colon. Underneath that, and I have to be indented, say a certain number of spaces. 2 spaces is fine. The default in Thani is 4 spaces. Otherwise, it won't run. And then I'll just type print I, comma, I star 2, so I squared. If we run this, we see we get 0, and then its square, 1 and its square, 2 and its square, all the way down to, well, 9 and its square. You might have thought that this was going to go up to 10, but the way this range function works is that it starts at the first number and goes all the way to 1 fewer than the last number. That is, it's the last element exclusive. It excludes the last number. That's just the way it's built. So if we wanted to run it to 10, we would put in an 11 here and run it like this. Now we're going all the way up to 10 and 10 squared. So each time through, what's happening is this value of I is changing. It's starting at 0, and then it's going to the next value in range, which is 1, the next value in range, which is 2, and so on. And it's just repeating this operation of printing each time. We can see something maybe slightly more interesting if we introduce another variable. So now let's start off with something like, let's start off with a variable that increases. We'll take x and we'll add I to it each time, and maybe now we'll print out x and print out I and x next to each other so we can see what's going on. If we run this, we get an error because what's happening is that Python goes through the loop. It sets I equal to 0. Then it comes in and it tries to evaluate the right-hand side, but it doesn't know what x is, so it can't compute this. And what we see is a fairly helpful error down here. It says name x is not defined. The last part of the error is saying this. Before then, it's telling us a little bit more. It's telling us, for instance, what file this was, the error was committed in, and even what line what line the error showed up in. In this case, line 3. So we can fix this, of course, by just defining x to be, for instance, 0, and then it should run fine. And we see something like this. We see a list with just I on the left, and then the value of x each time. And it's kind of curious to take a look at what's happening here. So x starts at 0, then we add 1 to it. The next time when I is 2, we add 2 to the new value of x, which is 1, getting 3. Then we have a 3 plus 3 is 6, 6 plus 4, 10, all the way down the line. We can see what's going on maybe a little bit easier by using this menu up in view and then variables. If we restart, so currently, even though the program is done running, I still has its last value of 10, x has its last value of 55. But if we click this debug current script, we enter into debug mode, and then we have these 4 options up here available to us. So we've got step over, step into, step out, and resume. So let's take a look at the step into command. So Python, well, Thani has highlighted the first line here. Well, the first line is, the real first line is a comment. It skips over the comment, and it's looking at the first thing it can do, which is just this x equals 0. If I click step into, it first looks on the right-hand side of the equal sign, sees that it has a 0 there, and then analyzes the line and stores 0 and x. Then it sees this whole for loop, and as we go forward, it looks at the range. It says, okay, I need to start at 0. I'm clicking each time here. I'm going to end at, well, the last entry is 11, so I'll end at 10. And then it says, okay, well, that is currently 0, and I'm going to put that in for I. X is 0, so there we go. It looks at the value of x, which is 0, the value of I, which is 0, adds 0 plus 0, and stores it into x, which is still 0. Next time through the loop is a little bit more interesting. So there it's seeing what to print. Okay. And when we come through the next time, now I is equal to 1. And it looks and says, okay, well, x, what's my current value for x? Well, it's 0. What's my current value for I? That's now 1. And so when I add those together, I'll get a 0 plus 1 that's showing the sum there, and then that's stored in x. And when I print, I'll print a 1 for the I and a 1 for the x. Let's go one more time. So now I is 2. X was, it looks to the stored value, x is 1, I is 2. Add those together, we get 3. And store it in x, and when we print, we'll then be printing 2 and 3, just like, well, we'll see it print in just a moment as we step forward. There we go, 2, 3. So we can really see in fine detail what this program is doing. Sometimes that's a little bit too slow, and we can use step over to skip certain parts in the debugging. So if I click step over, it's kind of going a little bit more line by line. Sometimes if you're deep inside of a loop, you can use this step out to get out of a loop. And then if we want to just let the program do what it's doing, we now understand it, or where any bugs might be occurring, we'll just hit run and the rest of the program executes. Okay, it also takes us out of debug mode. So if we want to go back in, we'd have to click this little bug icon up here. So that's some basics of how to write a loop. Next, let's look at a nested loop. So to do this, this is useful when you're doing things with, for instance, 2D arrays, also known as matrices. Let's get a little feel for that. So in order to do this, let's use an array structure. And for that, I'll import numpy as np. And then we'll start off with an array. So the first thing we need to do is make space to store the numbers. So let's go with a 3x3 array. And then we will, we don't need this x anymore, but we'll have I goes from range 0 up to 3, remembering that this will count 0, 1, 2. And then on the next line, we'll have a second index. So for j in range 0, 3, like this, then we can say a, and then let's say ij equals, let's do something like I plus j, and then that's it. We'd like to print, well, we could print on this line, but what will happen is that this will print out the value of a every time through the loop. So let's see what that looks like. If we run it, we get probably more information than we were hoping for. We get a 3x3 array, which starts at 0. Then we get a 1. Then when it's something else has been added, we get a 2, and so on all the way down the chain until we get the final result. In this case, we might just want the final result. So we can do that by just moving the indentation over. So the idea is that this operation using the aij is happening inside of the j for loop. This operation, so I get set to 0. Then j gets set to 0. Then we evaluate the 0, 0 entry of a and set it equal to, well, 0 plus 0. The next time through, we're going to go up just to the j, because we haven't gone all the way through the j loop yet. Now j will be 1, and I will still be 0. And when we add those together, we're getting 1, which is showing up in this first bit, and so on. So we'll complete the entire j loop and then go back. I will change to 1. We'll do another pass through all the values in the j loop, and then I will be 2, another pass, and then we'll be done and print out the result. There you see it happens pretty quickly in Python. Again, though, just to see that in a little bit more detail, if we go into debug mode and step forward, maybe we'll do step over this line, step over this. But now, if we look to our array, which is actually a little bit hard to see there, unfortunately, but we can at least see the top line as we do a step into. We can see I is 0, j is 0. We add 0 plus 0, get 0. But now j is 1. And as we've added these together, we get a 1 in the first slot of the array. As we go, j is now 2. As we go forward, we then go back and increase I to 1. J now gets reset to 0 because of this range function is starting that j at 0. And so we should see here in a moment, after it evaluates, j is back to 0, and then we'll go through, all the way through. All right, and there we go. So this is called a nested loop. A nested loop is just a loop inside of a loop. So not too bad for something like that. Next, let's look at while loops. A while loop is similar to a for loop, except for we don't tell it necessarily how many steps to go through. We give it a condition telling the loop when to end. So this can be useful when you don't really know how many steps you need. You just need to end after some point. So I'm going to start with a kind of contrived example. And this is to find the largest, say, factorial number less than a given number n. So for instance, let's say n is equal to 200. And if we remember how factorials work, for instance, if we did 5 factorial, this would be 1 times 2 times 3 times 4 times 5, like this. So a common strategy for computing a factorial is to start at one end and go all the way to the other, multiplying as you go. So I would have maybe some number like 1, and then multiply by 2, multiply that same number by 2, multiply the old number, then by the next number in the chain, 3, and so on, all the way down the line. So let's see how to do that. I'm just writing this here for notes. If I write 5 exclamation mark, Python won't compute a factorial, at least. So, all right, so what we would like to do is loop, but with a while loop. So if we say while, say, factorial, some factorial number that we'll define in a minute, is smaller than this n, then take the factorial, the variable fac, and multiply fac by I. So this is the thing we'll be increasing. So let's initialize that. We'll need I equals 1. And then on the next line, we need to increase I. Notice that I is not showing up in the for loop. It's not going to be increasing by itself. So we'll have to increase it sort of manually like this. I equals I plus 1. That'll increase it each time. Or if you prefer, I plus equals 1, we'll just increment I by 1. Okay, great. So this seems maybe reasonable, but we still have to initialize fac, and let's print. So we'll print maybe I and fac as we go. You might guess that it's a common mistake to implement to initialize factorial by 0, but of course then we'd be multiplying by 0 repeatedly. So in this case, we want to initialize with fac equals 1. If we run this, then we get here I. Notice that I started at 1, and it's updated before we print. So its first value in the print function is 2. And then we're running all the way up to, well, a little farther than we wanted, up to 720. Now, if we didn't know in advance how, for instance, that 5 factorial was 120, not bigger than 200, but then the next factorial was 720, bigger than that, we might not know exactly how long to run this loop out for. That's why a while loop can be a little bit handy. So, all right, but we're not printing out the number that we want, and really we only want the last number here. So one strategy to do this is just divide by I. We've just increased I by 1, so we can divide by the last number in the chain, but we have to subtract 1 because we're adding 1 right before that. And if we get something like that, then the last number printed out is 720. Of course, if we put this print statement before the addition there, we get something, oops. Oh, right. The first time through, I'm subtracting 1, which is no good. So let's keep the print statement after. Okay, so we get something like this. And we really don't care what the value of I is. It's just keeping track of our multiplier as we go. So maybe in our print statement, we won't include that. And we'll also move our print statement over to the left, meaning it's no longer in the while loop. It'll only print once everything is done. So if we do that, we get the largest, we get a factorial number, which is less than 200. So if we test it, for instance, let's choose something between 24 and 120. If we run that, sure enough, we get 24. So this is giving us the biggest factorial number that's less than our given number. If we go all the way up to something like, say 1,000, or let's say 10,000, then we get 5,040. And I think that's not so obvious how many times we would have to, how many numbers we would have to multiply together to get this number. So this can be a pretty useful tool to use if you don't know how far along to go in your sequence. All right, so great. Let's go. I want to show you one more example. So we've now seen for loops, nested loops, and while loops. Let's take one more look at something a little bit more interesting, which combines a lot of the tools that we've seen so far. So for this program, this will print out different polygons of different sizes with a different number of edges. So we'll start with 3 edges and go all the way up to, well, 10 edges, right? Because we don't include 11 here. And to do that, I'll use some angles theta. I'm using linspace here to run from 0 up to 2 pi. But I want to include one additional point all the way at the end so that my polygon loops all the way. So an n-dimensional polygon, I'll need to connect the last point here. So I'll have one additional point. After that, we'll just use a subplot, which we've seen before. So this is 2 rows, 4 columns of a subplot, and it's just counting i's going from starting at 1 and then increasing as it goes through the loop. After that, we'll just plot. And remember that when we take our numpy cosine or numpy sine acting on a vector, it'll take the sine or cosine of each number in that vector. So here we're getting a whole bunch of cosines of all of the angles and sines of all of the angles, and they're plotted as just x and y coordinates as we go around. Yep, so let's take a look at what happens. If we run this thing, we get, sure enough, some nice polygons showing up. Notice also that in the title, we have a variable title. So this says print title function, or excuse me, format. The format that's going to be used here is n equals, and then this n in curly braces is evaluated with its actual value. So first 3, then 4, and so on from the loop. So we get something like this. Printing out. Now, I think this would be a little bit challenging to do without a loop. It would at least be a little bit tedious to do this. Here we have just a fairly nice compact thing. I've also included this plot axis square just to show you what that's for. If we don't use that, then sometimes we can get something which is looking a little bit wonky and stretched out. So that's why I've used the square to make the axes, the x and y lengths be the same for these. So there you have it, some basic ideas behind using for loops, while loops, and nested loops. Happy plotting.